This is construction number 11. This is the final construction that we're going to do as a class. And with this one, this is another one that I really enjoy. This is where we're going to be given a triangle, so it's very similar to construction number 10, but we're going to inscribe a circle within the triangle. So what we're going to do is basically draw a circle that's going to intersect each one of these sides at exactly one point. Or think of it this way, each side of our triangle is going to end up being a tangent line on our circle. And the way we do that is we're going to bisect each angle, or at least two of them, and we've learned before that the angle bisectors of a triangle are concurrent. They're going to intersect at exactly one point. So using that property, let's go ahead and see what happens here. You're going to bisect at least two of the sides, because if they're concurrent, if they're bisecting two sides or three sides, they all should intersect at the same point. So use your process for bisecting angles. Draw your arc, and then from the intersection of that arc, figure out another point equidistant to that. That's going to be the angle bisector for that angle. I'll do the top angle here. Make sure I hit the actual vertex here. So again, drawing an arc through both of our sides of our angle. Then I'm going to go a little bit bigger so I don't get confused as to which point is intersecting what. Keeping that same arc length, find out where that intersects. So the segment that connects the vertex with the intersection of those arcs should be the angle bisector for the top vertex. So these angles should be congruent to each other. And then just for good measure, let's do that third angle. See if we indeed have concurrent lines. So we're bisecting this angle to just make sure they intersect. So it just has to be at least over halfway. So got that intersection. Draw our line between any 2 points. Exists exactly one line. Hopefully a little bit off, but that'll do. So our point of intersection is somewhere in here. So we know that this point is going to be equidistant from all three sides of our triangle. So if you want to find the distance from a point to a line, the way you do that is you have to draw the perpendicular segment, or measure the perpendicular segment. So this is our most involved by far construction. So we want to draw a line that's perpendicular to this point of concurrency to one of our sides. So I'm going to choose this one on the bottom just because I think it's going to be the easiest. So you kind of do your little anchor thing to create a segment that's got that point on the perpendicular bisector. Constructing a perpendicular from a point not on the line. So here we go. That should be the perpendicular to that side. So this segment right here should be the radius of the circle that gets inscribed within this triangle. And I'm a little nervous that this isn't going to work out because it wasn't quite perfect when we lined it up earlier, but hopefully it's at least close enough. So when we draw this circle, yep, little off. But that's the process or basic idea that we want to go through. So I'll do it again. Hopefully on the next one it works out a little better. So we're going to do the angle bisectors of two of our angles. Again, it doesn't matter which angles you use here. So I'm going to do this one to start. Oop. Do this one to start. Go out here. Find that point of intersection. That's going to be our angle bisector. Trying to focus here because it didn't work out last time. So that might be a little bit off, but I guess we'll find out. So bisect another one of the angles. I'll do the obtuse one just because it's right here. Bisect this angle, so draw an arc that goes through both sides of your angle. Then making sure your compass is at least over half the distance between those 2 points. Draw 2 more arcs that intersect. Connect that point of intersection with the vertex of your triangle. That's going to be the angle bisector. And those should intersect each other, and this point right here should be our point of concurrency for all 3 of our angle bisectors, hopefully. So now, again, we want to draw the perpendicular segment from this point to a line, so I'm going to do the base, and to make sure that I have it done correctly, I'm going to just extend this line a little bit. I'm going to do it in red so that we can see that that's just an extension of that line there. So using this point and our compass, drop the anchor and go down below to draw the perpendicular line from that point. So that's our point of intersection. Connect those 2 points. That's going to fall on the perpendicular bisector of that little segment we just created. So hopefully here we can measure that out with our compass, and hopefully we'll have a triangle or a circle that's inscribed within this triangle. So far so good. And it works out. That one actually worked out a little bit better, which is encouraging. So bisect 2 of your sides. Once those 2 sides are bisected, find the distance from that point of intersection to one of your sides. That's going to be the perpendicular segment. And then use that as a radius, and it should be the same from that point, the same distance to each side of your triangle. And that's how you're going to inscribe a circle within your triangle.